what, in your opinion, is the most valuable idea at this point in human history?
The most valuable idea.
To you personally?
Ah, I never think about that.
So the last guest, just to give you an idea, that the last guest I had said gradient descent, which is classic of a machine learning guy. But so you could feel free to say
Yeah, yeah,
anything.
yeah, 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 yeah. I agree. AI is the most important thing in our lifetime. And yes, actually, I also try my best to keep track of the progress of the AI industry, although I'm not uh, actually doing any research on AI, but I try to be the master instead of the slave of the AI. So, yeah, of course, we should do that. We should believe in the trend, the future of AI, and control it and use it, take the advantage of it. So, for the benefit of our life and career. Yeah.
An honor to be here with you, Dr. Leo. So it's my understanding that you grew up in Ordos in Inner Mongolia, born sort of 1990. Would that be correct?
I was born in Ordos
Okay.
in Mongolia, and then I moved to Balto industrial city in Mongolia, known for its rare earth and steel industry. And also, when I was 12, I moved to Hohhot, the capital of Inner Mongolia. And then I go to Beijing for university, Peking University. Yeah. And then I go to
Interesting.
Australia in 2016 for PhD.
Right, right. Okay. So one of the things that I was wondering is, I read that your parents gifted you your first telescope, and I also read that you mentioned they spent roughly 2 months of their salary, which is a pretty big sacrifice, in doing that for you. And I'm sort of
Yeah.
curious, and I think a lot of other people who are young would appreciate this. What In what way did that impact the way you viewed the world, the way you viewed astronomy, and then, in what way did that sort of pivot you towards that?
Okay. Let me explain the salary thing. Okay. The telescope was about I think 800 RMB. At that time it was 1996. So that's about $100. Okay, $100. So my parents, I think they have a salary about 200 or 300 RMB per month at that time. So I say it's about 2 months of their salary. Yeah. Uh, yeah, of course that telescope was I was quite proud of having a telescope at that time. And uh, as a kid, I was always proud that I can show my friends the moon when they visit my home. Uh, but actually, I think not until I entered the high school that I really was capable of using the telescope properly. Because when I was a kid, I actually didn't know what the telescope can see. So I only know it can see the moon and the sun. I didn't know it can also watch the Jupiter or other planets or comets or other nebula clusters or anything else. So it was until I entered high school and we have a astronomy club. And I entered the astronomy club, and my other elder students taught me that I can do this, I can do that. And I thought, uh, can you hear me?
Yep, yep, I can hear
Yeah,
you.
okay. Yeah. Uh, and also I
Interesting.
was
Okay.
preparing for a astronomy Olympics uh, competition for the high school students. And during the preparation for that Olympics, uh, I think I finally became qualified as a astronomy amateur. So that was my way of learning astronomy when I was young. Yeah.
Interest, Interesting. So it sort of started off earlier on when you were six. It sort of developed and matured a little bit more when you got into high school.
Yeah.
And then you decided to pursue it professionally, right? As an undergraduate. And sort of, was it the high school experience? Was it even earlier on, or was it, a combination of both that led you in that trajectory? Because I think most people when they're younger, right, they typically tend to chase after what they perceive as being the highest financial reward career, right? And so rarely do people get into astronomy, um, and it really has to be out of interest that you go into it. And so what was the sort of, was there any pivotal moment? Was there any one thing, or do you see it as more of a natural transition from all the things that you'd experienced in the past?
You mean why do I finally choose to go for astronomy, right?
Right,
Yeah.
as an undergrad.
Yeah. Actually, I was also quite influenced by some science fiction works. For example, it's Liu Cixin, a well-known science fiction writer in China. During when I was in the middle school. Uh, and his work influenced me a lot, and so I was very passionate about physics. So actually, I wanted to go to the physics school of Peking University, which is the best physics school in China. Uh, and luckily, astronomy department is part of the physics school. So if I choose to go to astronomy, I can also go to a physics school. So that's my two dreams: study astronomy and study physics. Uh, and then uh, there was some luck in it because uh, the year that I entered Peking University, there was a change in the uh, how to say admission procedure. Uh, so before I entered Peking University, the astronomy department they hired their students from like some senior grades. So freshmen will learn everything. They will not choose which major to go into. But because too few students wanted to go to astronomy, so uh, astronomy department uh, began to have less and less students, and uh, the department is going to die actually. So so in the year that I entered university, they decided to change. So they started to get students from the first year. So when you uh, so after the Gaokao, the high university entrance examination, we must choose if we want to go to physics school of Peking University, we have to choose we go to physics classes or go to astronomy classes. So I chose the astronomy one. So that is uh, because let me say this because that is the first year of this policy change. So the astronomy department fear they will not get enough students. So they offered a 10 points lower uh, admission line. So I can enter Peking University with a little bit lower uh, points. So that's my case. So I need that 10 points to get into Peking University. So uh, so of course I love to choose astronomy because I wanted to study astronomy. So that is a very uh very good policy for me, very in time. Yeah.
Right. Very timely for you, I guess.
Yeah,
And so
very
you
timely. Yeah.
mentioned You mentioned, which I think a lot of sort of people here in the West don't understand very well. Peking University is, you said, the most prestigious in China, and that's my
Yeah.
understanding as well.
Yeah.
Interesting. And so you,
Uh, we often call it top two. So another top two is Tsinghua. So Tsinghua is good at engineering, and Peking University good at science and arts.
right? Okay, interesting. And so you did your undergraduate there, and then you moved to Australia, to the University of Western Australia, to do your
Yeah.
PhD. And so what
Yeah.
what what are some of the things that you found as being different the way science is conducted, there in Peking versus in Australia? Were there any noticeable differences to
You mean
you?
the
Not technical differences, but sort of in the way and procedurally science is done.
ah um maybe one thing.
Hmm.
Uh, Chinese universities does not have big telescopes. So traditionally, the big telescopes are built and owned by the Chinese Academy of Sciences. So the Chinese universities, they usually only have very small telescopes for education. So, if we want to do science in universities in China, we need to cooperate with either the Chinese Academy of Sciences or other foreign institutes to get the data that we need to use for astronomy research. But in Australia, the University of Western Australia, they participate in the building of SKA, the Square Kilometer Array. So we have plenty of data. So I think that is one major difference. So when I was uh, so uh, so during my undergraduate, when I was doing the thesis, actually I was using some archive data that was used by others before, and I'm digging something more out of the data. But in ICRAR in UAA, I conducted the observation by myself. I was using the ATCA telescope, and I observed for more than 800 hours. So I think, um, of course, in China, for university students, they can also apply for others telescopes. We can apply for it, right? So yeah, but that still is one major difference, that in China, for students and the researchers in universities, they relatively lack the access to data. Yeah, that
Right.
is one.
And did you evaluate any difference in rigor?
Uh, what do you mean? Sorry.
Was there any difference in sort of the difficulty of the work being done, or sort of the complexity of the work that was being done, that you found to be sort of different from one place to another, or was it somewhat the same as you'd experienced?
Uh, I think because I stayed in NAOC, the National Astronomical Observatory of uh, CES, Chinese Academy of Sciences, for 3.5 years during the first phase of my PhD. And then I moved to Australia, moved to Western University of Western Australia for another 4.5 years. Uh, so, uh, so that is two phases of PhD we can compare directly. So I think uh, during the PhD phase, uh, it's more the impact of your supervisor is bigger than the impact of where you are or which institute you are in. So uh, my two supervisors in China and in Australia, they have somewhat different uh, way of tutoring students. So my my first supervisor, uh, he wanted more the students to solve the problem by themselves. And my supervisor in Australia, he tend to uh, supervise something very uh, in detail, something very subtle. So anything that even if very easy that I cannot do, I can ask him for help. So maybe that's some personal difference.
Interesting. Um, I think you're being quite nice, but I think there's a huge difference from what I understand in different in rigor. I know that in China they tend to be much more detail oriented, much more sort of able to sort of understand and sort of deal with a bunch more complexity, um, which I find in the West is lacking. And I could say that because I'm in the West, so I could criticize them. So moving on to something else that I find super remarkable about your story, which is while doing a PhD, you decided to go online and start sharing sort of and doing science communication. And
Yeah.
as most people who've done a PhD know, it's an extremely overwhelming thing to do in and of itself, much
Mhm.
less adding something on top of that. And so, what drove you to do that while doing your PhD as opposed to doing it after, which I just find amazing, frankly.
Yeah, I think uh, the story still starts from when I was in high school because I entered the astronomy club and some other elder alumni uh, taught me or introduced me into astronomy. So I was quite moved and influenced by their sacrifice or contribution. So I think I should do the same to my younger fellow students. So I wanted to contribute to the grow up uh, of other kids. So the kids after me. So when I was in university, I entered the what we call it YAS, Youth Astronomical Society. So that's a astronomy club in the university, in the Peking University. So uh, during that time, I was already switching uh, my time, allocating my time into the science outreach affairs. So during my PhD, that was just a extension, or I was trying to find more ways, more different ways to doing the same thing, doing the science communication. So uh, actually, when I first entered the PhD study, uh, I began to write something. There was a new website called Zhihu, which was started by 2012, and I entered Zhihu by I think 2013. And then soon after that, I participated in a competition, a science communication writing competition in Beijing, and I got the first prize in that competition. And because of that, I got a chance. I even got a chance to meet with the then vice president of China, Yuan Chaoli, Li Yuanchao. So he as a vice president, actually he was uh administrating the science and science outreach affairs in China at that time. So I got a chance to meet with him, and I spoke for 5 minutes at that time. So uh, such things are all stimulations or encouragements for me to do more science communications. So I was soon awarded a annual member, something like annual excellent member or something of Zhihu. Zhihu gave me that prize. And then uh, yeah, then I also started my Weibo. Weibo is like Twitter in China, and I have about 1.2 million followers in Weibo right now. So uh,
Oh,
yeah,
so that's fascinating. So it's primarily as a result of sort of participating in a competition, also some of the work that you've done when you were younger. I find that super fascinating. But in addition to that, your formal research is also pretty groundbreaking in its own right. So you focused on cold atomic hydrogen in the Large Magellanic Cloud, essentially
Mhm.
studying sort of the raw material from which stars are formed.
Yeah.
Not be familiar with galactic chemistry. Can you explain why this is so crucial for understanding how galaxies create stars and sort of what it is about that research that was important?
Okay. Yeah. My PhD work was focused on the Large Magellanic Cloud. Actually, that's a galaxy that can only be viewed in the southern hemisphere. So I moved to Australia to continue the research. Uh, During my first paper, actually, I was using uh, some archive data released by the Australian researchers. Uh, and I was using a method uh, developed by my supervisor called HINSA. HINSA is a way we use to define and the way we use to find the very cold neutral hydrogen inside a molecular cloud. And my second work during my PhD was, as I said I observed for over 800 hours with ATCA. ATCA is a interferometer. We call it uh, interferometer is a kind of radio telescope array. So we use six telescopes, each with 22-meter diameter. So they form a huge array. The longest baseline is about 6 kilometers. So it can operate as a whole giant telescope with has a uh, diameter of 6 kilometers, so it can reach a relatively high uh, angular resolution. So using that, I observed some dozens of background radio sources towards the different directions of in the Large Magellanic Cloud. So the LMC, Large Magellanic Cloud, we call LMC, it is like a disk, uh, almost a face-on disk. So if we observe different directions of in the disk, actually each direction, the background source is working like a torch or something. So or candle, it can project some light towards us, and the foreground, which is the cold clumps, the cold clouds in the LMC, works like something foreground object that can block some light. So if we study the spectra, we can find where we can have a absorption. So if we analyze the absorption and the shape of the absorption lines, we can find the uh, composition and the properties of these cold clouds in the LMC. So we can understand more how the interstellar medium evolves in the LMC and how the stars formed in that. So that's basically
Fasc-
my work.
Fascinating. And so that was the Parkes telescope, right? The
Not parks. ATCA is nearby
AT
park, but not parks. Yeah.
Interesting. So one of the things that I found fascinating, given that I do sort of machine learning, is that you have to merge and sort of ingest all the data into one. And was that sort of the problem that you guys faced when you were dealing with that? How is it that you sort of dealt with this that you needed to sort of unify the data sets for?
Yeah. For the dozens of sources that I observed, each source was observed for at least 12 hours. Some will have more observation time. So yes, we need to combine all the data together, all the data for one source together to get a integrated spectra. So that is the standard procedure for astronomy because astronomy is dealing with some very faint sources. So we need to very long exposure. Yeah,
Interesting. So you worked on sort of your own tracking software, right?
yeah,
That
for the space station.
can you sort of walk us through a little bit what that involved? And was that your first time sort of was that your first time sort of picking up programming, or had you sort of done stuff in that realm before?
Yeah. Uh, of course, we need to do programming for the PhD study, and that is not my first time doing the programming, of course. But
Okay.
anyway, I'm not majored in CS, so I'm not a expert in programming. And the data processing pipeline uh, during my PhD, actually, I share the same pipeline with my one of my collaborator. So because the pipeline was shared, so I didn't need to write the whole pipeline myself. I just need to do some little adjustment during the use. So for my space station tracking program, I write all the codes from bottom up. So from from line one. So uh, I did it did everything by my own. So that was a little bit challenge for me because uh, and another thing that is a challenge for me was uh, to track the space station. I not only need to deal with the software, the data, I need to deal with the hardware too. And something that I struggled for a long time is that I was not quite uh, understanding how the hardware can be controlled by the software, and which library or which software can work as the bridge. So in the last, I found the right thing, which is ASCOM. So if we look back, it is a very common thing used by the astronomy community, especially the optical observation community. But I didn't know that because maybe because I worked on radio astronomy and I did nothing about optical observations during my PhD. So for me, I didn't know that. So it took me a long time to discover ASCOM. So that was a very nice tool. So with the help of ASCOM, I uh, did the I successfully controlled the telescope as I needed, so I can track the space station with a very simple algorithm. So,
Right. And it must have been quite nice seeing some of those first images coming in of the space station.
sorry.
My understanding is you
Mhm.
guys got it to a resolution. I said it must have been quite nice seeing some of those first images coming in
Yeah, yeah, yeah,
of the
yeah,
Tiangong space station. That's
yeah, yeah, yeah.
amazing.
Yeah. In 2012, that year, uh,
Hello.
the Tiangong
Sorry, I
space
have
station
some.
was in the Tiangong space station was in the second phase of its construction. So the first phase is called something like a experiment phase. So that took 1 year, starting from 2021 April. So in the second year, it began the so-called construction phase. Uh, when the Tiangong station changes very fast. So in a few months, in about half a year, it will go through 12 different configurations. So uh, there's the Shenzhou spacecraft, which is for human, uh, and the Tianzhou spacecraft, which is for the cargo, the cargo ship. And there is the core stage, and there is two labs. which is the Mengtian and the Wentian, the two labs. So the different stages, they need to um, go together to make a whole space station, and the whole process is quite complex, and it change a lot. So I wanted to record this very, I think, very important and very precious moment of the Chinese space history. So I did this project. Yeah.
And I think it was widely celebrated across Chinese media, correct? I think it's a fascinating achievement.
Yes.
So your work goes from creating and sort of complex technical issues, to also having to deal with some of the human delusions that exist. And so, while you were still a PhD student, you made the bold decision of sort of publicly exposing cult-themed sort of social media accounts promoting alien enlightenment, is my understanding. And one of the most prominent of those was the Galactic Radio Station. Um, and so, these are some of the people that we're calling sort of alien contact, some spiritual figures like Buddha was making contact with them. Um, you know, that's one would view that as sort of a 180 from somebody who's, really focused dealing with technical issues. What drove you to sort of wanting to deal with that, which in many ways I'm sympathetic to.
Okay. Because basically I'm writing everything about astronomy. So I think uh, looking for the aliens is the job of astronomers, especially the job of radio astronomers. So if someone else claim they have found aliens, it need to be certified by astronomers like us. So, but actually we all know that's all lies and maybe some frauds, or they they want to do something with their own purpose. The purpose may be money, maybe power, maybe something else. Maybe they just have something wrong with their mind, maybe. So any possibility is so I think that's not a religion. That's not religion. That's so I call it cult because I do have some real examples that young kids, uh, their minds got jammed by these stories, these make-up theories. So uh, some students maybe they are in the junior middle school. The uh, So one example, the little girl in Qinghai province, she was in the middle school, and she believed in these things. And then he got I don't know how to say that in English, 精神分裂. So that's a s- a kind of
A
mind disease. So
psychotic breakdown.
yeah, like that. Yeah, yeah, yeah.
Okay.
So uh, although she after she contact with me, and I introduced some other experts to her, so she gradually uh, got the things got her mind right. But I mean, she stopped believing those things, but she still suffers from the trauma. So uh, she had to stop studying and stay at home for several years to get back on track. So I think that is not the only example. That's if we find one example, maybe there are 1,000 or 10,000 such kids in China that is have their mind polluted by these crazy theories. So I think I have the duty to tell people the truth.
Yeah, I have profound and deep respect for that. I think, one of the things sort of in the Western side of things is, you have cults, and I think you sort of talked about them in the past too, like Heaven's Gate and realism, and so these things can cause just as much danger. And I find it fascinating that your approach to it was sort of at an individual level, sort of looking at how it could impact, kids and younger people with, in many ways also speaks to your degree of empathy for these things. Um, and so is there any, I'm sure you've sort of tracked the narrative that's been progressing here in the West in regards to aliens and UFOs. Do you
Yeah.
have any ideas as to what you think that might be as a result of, or in what way you would sort of approach something like that? Um, I understand there's similar myths on the Chinese side, um, but how do you contrast these two sort of narratives in many ways?
Uh, I think most theories, most such UFO religion theories in China right now, they are imported from the West. So they are, I think, simply translation from the West. Yeah.
Right. Do you have any ideas as to why? I think China's been much better, much more detailed and uh, in understanding this and also in sort of dealing with not allowing the narrative to get too out of control and diluting people at mass scale. Whereas in the West, I think people have sort of seemed to not care anymore. And sort of there's this self-propagating nature of this narrative. And again, at some level, people are, extremely curious about the universe, about reality, as you were when you got into astronomy. But I think the methods and approaches they take to sort of channel the energy of that curiosity um, can get sort of dissuaded by people who claim things. One of the interesting things that's happened here in the West, especially since 2017, that sort of led people to think that there's a lot of credence behind these things, is that the government came out in many parts and said there's credence to this. Is there anything of sort of similar origin in China where, reputable figures or governments have come back and assigned their reputation to the credence of such a thing? Which
Yeah.
even smart people like yourself, I assume, have to look at that and think, you have to think twice about that, right?
Yeah. Actually, in the 1990s in China, there was a wave of so-called Qigong, I don't know how to translate that, but so people were crazy about Qigong. Qigong is like a super ability of human, so you can move things remotely with your mind or something like that. It's crazy. So during that movement, there was a very famous scientist called Qian Xuesen. Chen Xuesen, the founder of JPL actually, one of the founder of JPL, and he came back to China and helped China to build the nuclear industry and the
Oh,
missile
yes,
industry,
yes.
space industry. And he was a very famous scientist in China. But when he got old, he endorsed the Qigong actually. So that's one of the reasons that people uh, got confused in the 1990s. So actually some of the cults originate from the Qigong movement. So like Falun Gong, maybe you have heard of it. Uh, the that's actually Falun Gong is the most notorious cult in China and was depressed by the Chinese government. Um, and so yes, sometimes some famous scientists or the government they also made mistakes in history. So that's also one of the origin of these cults. Yeah.
That's interesting. And do you think in any way, we now live in sort of the digital age, which is very different from that age, where information sort of self-perpetuates much faster. Do you think that there's sort of, and I think partly your work and the way, you sort of communicate science is helpful in sort of helping people understand what's signal versus what's noise, to put it mildly. And so, do you think that it's the problem is just exacerbated now that we're in a digital age, where it's really difficult to understand what's truth and what's not?
Ah,
And also just to add to that, do you believe or do you have sort of a thought that, there a healthy level of both being critical of such things, but also not being so critical that you don't allow new information to come in and evaluate that. And I know that you've built simulations, even sort of trying to understand these things. And I think here in the West, a parallel to what you've done, a contemporary of yours would be someone called Mick West. He used to be a video game developer. I think he also built similar simulations.
yeah, I
Um,
follow him. Yeah.
yeah, yeah, yeah. So how do you evaluate that?
Um, sorry. What's your
So
question?
the digital age issue, which is sort of the point that these things are just growing in scale because of the digital age, and then also what approaches would you have for the ordinary
Uh,
citizen that is interested
yeah.
in this, perhaps isn't an astronomer, um, and would like to
You,
channel that energy?
yeah. Do you mean in the digital age, people have very wide access to different information sources, so it's more easy for the uh this misinfo
Right.
to
So it's
yeah
it's easier it's easier because people have more access. It's also
yeah
easier because the cost of distribution is much lower. So, Joe Schmo
yeah
from some
yeah.
village can also share random
That's a
information.
very nice point because actually that's also my thought because everyone can now publish something on Facebook or TikTok. So the production of contents, the threshold is coming down. So everyone has the right or ability to produce such things. And people similar people with similar minds, they will attract each other. So if someone believes in such cult theories, they will find other people who believe the similar things, and they will form a small circle that will resonate with each other. So they cannot escape. So um, other voices cannot break in and tell them you are wrong. So they just refuse to listen to anyone else. They just listen to each other. So that is one feature of this internet dynamic. Yeah.
Absolutely. And then sort of for the ordinary individual, and I meet so many people that perhaps don't have any technical background, but are just fascinated by this question because in many parts it's a human question. Um, how would you advise people like that to sort of channel their energy and their curiosity past, it's just sort of random ruminations of things that might not be as impactful? What would you say to the ordinary individual, perhaps in China or even here in the West?
Sorry.
How
What's
how 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 would you advise somebody to channel that curiosity when they're not an expert like you are?
ah you mean how do they pursue their
Exactly.
curiosity?
No, how do
Yeah.
they pursue this specific curiosity, their curiosity of understanding? Is there life elsewhere or is there not?
Ah.
Because that's what leads to these UFO cults, right? These alien cults primarily as a result of not having a good way to channel their curiosity.
Mm. So uh the thing that I do most is to explain to people what the UFO footage, UFO images they have got in their phone or on the internet. What exactly is being shown on the image or in the footage? So by doing so, we can explain that it is not something from the alien. It is something that we can explain. It is just a, a plane or a balloon or a kite or something like that. So maybe a ghost image in your camera lens, something like that. Uh, so I think that can explain maybe 90% of all the questions, but there are something that cannot be explained so easily that they have a lot of different theories and um sometimes I don't know how to persuade everyone out from that because even if I think I have explained it right, but they still don't believe. Um, yeah,
They assume maybe you're part of the secrecy or there's always a way to rationalize in your mind once you become a cult follower that, anyone persuading you otherwise is somewhat a bad actor. Um, I think that's partly one of the importance of people at your people like yourself. So in sort of pivoting to something different, you again, like mentioned, you have sort of deep technical expertise in something I'm very passionate about, which is astrophysics. Uh, but you also now have become a science communicator. And so this isn't, a very common thing at all. I think a lot of people who are doing PhDs would be very impressed, but also amazed that one could do two of these things at the same time and then continue to build somewhat of a good career in science communication. Do you believe that's the future of becoming a scientist, is the sort of dual path of both pursuing a technical academic degree and also communicating the information that you learn?
I think it's a personal choice
Fair.
or something about personality. Some people just want to focus on research. It's completely right to do that. And but someone else like me, we want to communicate with the public, and we feel we have the duty to do that. That's also a personal choice, and no problem. I think we do not require everyone in the science community to do the communications to the public, but I think we should encourage the scientists to do so. Yeah.
Yeah. Yeah, no, absolutely. I think it's paramount, especially in many ways, I found that when you teach knowledge that you've learned, you tend to sort of embed it in your mind better. And I think
Yes.
it can be helpful even from that point of view.
Right.
So some studies I've seen have shown that sort of communication in China about just sort of going back it can be paradoxical because if you position yourself as um, genuine, scientifically oriented, and credible. But then you also present yourself as, a Mick Westwood, which is heavily skeptical about something. You end up in this paradox of, okay, this person is just, a super skeptic and they don't allow new information. So how do you personally deal with the issue of, I'm open to new information. I am okay with understanding that some things remain unknown, and there is a possibility that those things could be true versus, there are some things that need to be verified and go through the scientific process.
Yeah,
How
yeah,
do you
yeah,
maintain that balance?
yeah. We have a gold rule for that. Great claims need great evidence.
Yes.
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 So
Yes.
we need to verify every extraordinary claims. Yeah.
Yeah. Right. Right. And I think that carries over to world. Um, right. And so you've also mentioned that the probability of alien contact is infinitesimally small, which is absolutely true. Why do you think then, outside of the sort of religious issues, perhaps even the sort of intellectual and intelligence issues, um, why people still fall for this exploitation?
Sorry, why what? Sorry.
Why people still fall for this level? Why people still fall for this exploitation?
You
So
mean
there's an
why?
abundance of people like you, right?
Yeah. You
Why
mean
why is it that
why
people
do
still
people still believe in?
yeah, despite people like you being out there, despite this being debunked forever, despite there being no evidence whatsoever of anything of that sort,
Uh,
um, do you think there's a sort of a
yeah, but
psychological aspect to us as people? that causes this?
Um, so although we have been talking about this for forever and educating people as much as we can, but uh, overall speaking, the society, whether it's in the West or in China, the general public, they are not very well educated in science, I think. So,
Yeah,
it's especially when these issues actually uh, you need to have very good background to think about this problem and to uh, recognize what is true and what is illusion. So that is a very high demand to the knowledge of the public. So I think it's really very hard to deliver what we want to deliver. And also, you are right. People have the tendency to believe in such things because they have the sometimes a very um we can say it's a beautiful childish dream or something. So they have the good hope of this thing being true, and that's not very evil. That's natural. But that is not based on science, they always make mistakes. That is also true. Yeah.
right. I think one of the things that I find, partly disheartening, is I think a lot of the reason that people tend to fall for this, or sort of get sucked up by it, is as you mentioned, where you have high credibility individuals who they perceive to have the bona fides, then helping propagate this narrative, I think is perhaps the only reason why a lot of people tend to get sucked into it. So changing gears a little bit, you've described sort of documenting science and space exploration as sort of a lifetime commitment for you. Where do you see yourself and sort of your aspiration for that goal in 20 to 30 years from now? Where at which point we might have discovered aliens, who knows?
You mean, is it possible that we really find aliens in our lifetime?
No, no, no. I'm saying, no, I was partly making a joke about that. I'm saying you personally, in 20 to 30 years, I understand that your
Uh-huh.
sort of commitment is to
Yeah.
document space exploration and sort of human endeavors in space in general. Where do you see yourself in 20 to 30 years? Do you see yourself as an even bigger science communicator? Do you see yourself going back into research and academia, or sort of living in between both?
I think I will do both. I will do both. Yeah. Because uh, doing science communication forever is not a very good choice because if you are always exporting knowledge but not getting knowledge, then one day you have nothing else to say. So everything is what I have already said. So I will lose the passion of sharing my knowledge. So I need to learn new knowledge and then at the same time outputting my what I have just learned. So that is the secret of keeping passionate about science communication. So I need to do some real science research to put myself at the frontier of science or the scientific industry. So to that is a way to keep my own passion on science communication.
Right. And then I find that for people like yourself, and hopefully for me as I continue to do my PhD, is that you find that, if you're fundamentally curious about these things, it's really never as fulfilling to just do communication, and not getting down in the weeds. And so I completely understand that. So this is somewhat more of a personal question as we reach the end. Um, so you grew up in a very different background, I think, to a lot of people here, and you've had a very interesting sort of life path. What is what are some of the principles and sort of values that you would want to model and you model for yourself, that you think young people growing up today would be better off having?
Um, you mean what personalities or what uh
No principles, so principles
principles?
that help guide you that you think would be valuable to others.
Principles.
Yeah.
Okay. I think we should honor truth over some personal feelings or some other ideologies. So there are some examples that during uh during May and June last year, I fight with people on the internet for about 2 months over two issues. The first issue was many people in China they do not believe the Apollo mission as many so many people in the US they make up the theories that the Apollo missions were a lie or made up by the government, and many Chinese people buy that because uh, is the reason is very simple because that is one thing that can prove the U.S. is bad because the politics, the geopolitics thing. So, the ordinary people in China, they want US to be proved to be bad. So, they buy this series, although this series is also invented by some US in the first place, US people in the first place. So, so I fight with these people for this because not because I do not love China, I love US, but just because I want people to know what is the fact. I think we should always put fact in the first place. And the second example, during the June to July last year, there was a there was a news that a girl in the vocational school, a girl in a vocational school called Jiang Ping. It was sad that she won the 12th place in a very high level math competition. And everyone, including me, were very moved and very crazy about this news. And we think, yeah, this girl can do this achievement. Although she is in such a very uh, normal and bad school, not a very prestigious school. Um, but 3 days later, I proved that this is just a propaganda by the company which organized this competition. And maybe that's a lie. Maybe they just didn't do any check. So actually, that student, we believe she actually didn't participate in the exam at all. Maybe she just um, handed in the answers from her teacher. So so during that time, there were some very fierce fight on the Chinese internet because many people were very feel very sympathetic to this girl because she's female and she did very well in math, in science. So people wants to uh, consider her as a model for the young girls. So at first, I also support the girls to attend science as a career. Um, but I think that should be based on facts. We can always honor the real female scientists, but we shouldn't honor someone who do not know any math and just was show up in a propaganda video and we buy it. We shouldn't buy that. So uh yeah, that is that is how I deal with that. So I love my country and I support girls, but I cannot allow people to uh put fact under these things. So we should always put fact above these things. Yeah.
I think that is an incredible principle. The idea of truth being above all, and I think that's perhaps what also brought you. It's definitely what brought me into science. I'm assuming that's definitely what brought you into science as well. Is not really caring about what people have to say and sort of finding out through a set of processes that can be replicated in anywhere you are. That's amazing. So one of the questions that I ask all my guests around the end, this might be a little bit unusual is what, in your opinion, is the most valuable idea at this point in human history?
The most valuable idea.
To you personally?
Ah, I never think about that.
So the last guest, just to give you an idea, that the last guest I had said gradient descent, which is classic of a machine learning guy. But so you could feel free to say
Yeah, yeah,
anything.
yeah. Yeah, yeah, yeah. Yeah. I agree. AI is the most important thing in our lifetime. And yes, actually, I also try my best to keep track of the progress of the AI industry, although I'm not uh, actually doing any research on AI, but I try to be the master instead of the slave of the AI. So, yeah, of course, we should do that. We should believe in the trend, the future of AI, and control it and use it, take the advantage of it. So, for the benefit of our life and career. Yeah,
Awesome. Well, thank you for the interview. I appreciate it, Dr. Liu. I hope we can connect at some point in the future. And this has been lovely. I appreciate it. Have a lovely rest of your day.
thank you very much.
Awesome.